Hello everyone, Arash Jafarzadeh here. Now that we've learned about the basics of your computer's hardware, let's take a look at your computer's software. Software is a series of instructions or data that is stored electronically on your computer's hardware. At its heart, computer software is represented as a series of ons and offs, known as binary code. In a nutshell, the hardware records each on as the number 1 and each off as the number 0. By putting a series of these zeros and ones together in a sequence, we can give them some meaning. For example, let's say that I want to use these two lights to communicate with you. Let's say that if both lights are off, I'm going to get the instructions to take a nap. If I flip the switch and I have the first light on and the second light off, that tells me to scratch my head. If I have the first light off and the second light on, that tells me to fold my hands. If I have both lights on, that tells me to wiggle my nose. This method of communication is known as binary code. Each on or off is a unit of data, known as a bit. In the example here, we have 2 bits worth of information. Each light is 1 bit. For any meaningful data, your computer usually works with a series of 8 bits or more. This opens up the possibilities quite a bit. Having 8 bits is equal to a byte. I have an example here that can help us elaborate on this more. Here, I have a series of 8 LEDs, which represents a byte worth of information. Each LED has an on and off switch. When my switch is in the on position, I'm sending the signal as 1. And when it's in the off position, I'm sending the signal as a 0. Let's say I have a keyboard, and when I press a key on my keyboard, I'm sending a signal to my computer, about a byte's worth of information. When you press the letter H on your keyboard, you're sending over 0, 1, 0, 0, 1, 0, 0, 0. That's the letter H. When I press the letter I, I'm sending in 0, 1, 1, 0, 1, 0, 0, 1. Now I have I. I just said hi. Hi, pressed on your keyboard, is sending about 2 bytes worth of information to the processor. Now that we have an understanding of how data is represented to our computer system, let's take a look at how that data is recorded. Now in the first part of our lesson, we took a look at some storage mediums. We had the optical drive, the hard disk drive, and the solid state drive. Let's take a look at this hard disk drive. Inside this hard disk drive, you have some platters along with an arm and a head that's made of copper. Now what happens is, as this platter is spinning, the arm is traveling over the surface. It's able to magnetize that surface and demagnetize it. When the head comes across a section that is magnetized, it knows that it's the number 1. When it comes across a section that is not magnetized, it knows that it's the number 0. I should mention a few things. You never want to have a powerful magnet near your computer's hard drive. It's like kryptonite to Superman. The magnet will destroy all the data that is recorded on your computer's hard drive. The other thing I'll mention is that your computer's hard disk drive, or any storage medium, is generally not very intelligent. It doesn't have any real processing power. All it knows is that zeros and ones come in and zeros and ones go out. That's it. Your processor is what's doing all the thinking. Let's take a look at another storage medium. Your solid state drive stores information using electrons. Basically, there are a whole bunch of small, tiny little cells, and when these cells are empty, it represents the value of 1. And when the cells are filled with electrons, it's the value of 0. There aren't any moving parts, so as I mentioned in the previous lesson, a solid state drive is very fast and very quiet. The last drive we'll look at is your optical drive, your CD, DVD, or Blu-ray drive. Usually you put a disk inside the drive, like the one over here. you'll notice that on the flip side, it has a reflective surface covered by a coat of plastic. Now what happens is there are small, tiny, microscopic pits and smooth areas known as lands on the surface of this disc. There's a laser on the inside of your optical drive. When it bounces into a pit, it hits a sensor and it's the value of 1. If it doesn't hit that sensor, it's a value of 0. You might be wondering, what's the difference between a CD and a DVD, or a DVD and a Blu-ray? I mean, they're all the same size, right? Well, a DVD's laser is much thinner, and because of that fact, it's able to store more pits and lands on the surface of the disc. A Blu-ray is a similar concept. The Blu-ray laser is even thinner than the DVDs, and so it can store even more pits and lands on the surface, allowing us to store more information. I'll leave you with a few thoughts. A typical MP3 is about 3.5 megabytes worth of data. That's 3.5 million bytes, or 28 million bits. That's 28 million ons and offs that are recorded in a single MP3 file. About 1 minute of video recorded on my iPhone is the equivalent of 177 megabytes. That's 177 million bytes, or 1.4 billion bits. 1.4 billion ons and offs to store 1 minute of video on my iPhone. A Blu-ray disc packed to the rim with features and video is about 16 gigabytes worth of data. That's 16 billion bytes, or 128 billion ons and offs. If every star in the Milky Way galaxy was the equivalent of 1 bit, we would have about 37 billion bytes worth of data in the Milky Way galaxy. Now it's hard to get an exact number, but if every galaxy was 1 bit, we would have about 50 billion bytes worth of galaxies in the observable universe. That's about 50 gigabytes worth, each with hundreds of billions of stars inside. If 1 bit was the equivalent of an atom, we would have about 9.7 million terabytes worth of data in a single grain of sand. See you next time.